Performing COT analysis is rather easy. You can check it here. From COT, first you need to do COT initializations, or basically select the initialization file. From here, UOT or COT initialization, and then click on COT ongoing analysis. This function currently works only on GPU. So you need to build the layout builder, which is combination of the layups and the UOT COT initializations. To check it again, I click on UOT COT initializations and I give the number. It doesn't matter what numbers, because the number of toolings and layers will be decided based on the layup. So I put 1 here, and I should load the layup here that we just created. So it would be the layup simple plate, and click on open. Now currently we have the base tooling, which is tooling 1, and we have 2 tapes corresponding to 2 kinematics that we created before, and we assemble it in layout builder. You could here add extra tooling here if you like. For example, I add extra tooling here, and I set the tooling number 1 the same as tooling number 2. The thickness would be automatically detected by the software. The material they could assign here, probably you cite in another video that we explain it in detail, all of the buttons and all of the inputs. If you didn't check it, please have a look at this. So we set the material, we set the number of tooling and tapes, and here is the boundary conditions between the layers, which is hit contact coefficient, and the delay will be read based on the layout builder, and the number of repeats of the layers does not matter here because it's only for UOT analysis. So you could save the initialization file or click on OK, and the initialization file will be created in their supplementary files. So if you go to the installation directory, from installation directory after subfile, you will see the UOT initializations. This file should be selected here. So if we go to COT initializations, we select that file that we just created. Then we need to go the COT ongoing analysis and click on and set a name for the COT. Then click on yes, and now it's ready to calculate the COT analysis. As I mentioned, it works currently based on the GPU only. So you need to click on GPU accelerator to activate the GPU, and then afterwards click on COT on GPU. So several figures will show up, indicating starting simulations. The progress of this simulation will show up on the these figures. You will see in this figure the temperature of the tape, incoming tape. Each object has a separate figure for showing the boundary for showing the temperature update, and there would be one figure which showing the whole layup update, as you see it on this figure, which shows also the arrays which are heated the surface, and their thermal update. You could use Shift and H to hold the simulations, and then use the arrow on the keyboard to rotate the view. You could use plus minus to zoom in and zoom out. So I press on plus on the keyboard, and I check the situations. I use the minus to zoom out. So what you see here is if I rotate this view a little bit, is a global layup. It shows that irradiated zone has an average temperature of this value and this value. Please note that our mesh is rather large, so all of the power should be distributed between these large meshes, and that's why we have a very low temperature. If you like to have a better indication of temperature, you need to have a finer mesh, specifically on the regions of the irrigation zone. Like that. And I go to the other figures. So this is the temperature situation of the ply tapes here, of the tooling. Temperature situation of the tooling. You could change the viewing angle, the light here with this light orbit, and changing a little bit the views. This is for the incoming tape. So at the right side is a nip point. And this is the first tooling, which is considered as a fixed temperature. So as you see here, our irradiated zone are heated and a very thick tooling. What we could do, we could assume that we can place the already applied tape at these regions, so we consider it as a tooling. So what we could do is close this window and go back again to the initializations. What we would like to do is making the finer mesh around the region of the irradiation zone. So we go again, we add the 3 toolings and 2 tapes. So we added the mesh of the tape as a tooling. So there would be 3 toolings. 2 tooling has the similar mesh, a similar size, is a big ones, and tooling number 3 is actually the whole mesh, which is a narrow tape which was already placed. So we have 3 tooling now and 2 tapes which will be placed later. We will check this again and we will see the situations. So you could select the object for that, the material, and the boundary conditions. We update it a little bit. And we keep on OK. So we recalculate it again. And we see what's the situations at the irradiation area. Please note that when we have a higher number of the object, the simulation takes longer because all of the boundary conditions between the layers should be recalculated. So the time consuming for simulation part grows a little bit exponentially. So we check again here this area. We try to rotate it at the better viewing angle. We use again Shift and H. So we use a Shift and arrow to rotate this. So now we got a maximum temperature at the irradiation like 230. We try to let it go on the area of the irradiation zone with the keyboard. So as you see here, this area is irradiated. And this is the area after the consolidation part. These yellow dots are indicating that a roller press is happening at these positions. So a roller is actually there in the optical part, but here for the representation we only show the nodes and we consider the boundary conditions of the nodes, which is representative of the roller, with these layers and the tooling below. So this is the current situations. And the simulation can continue, which takes some time until the whole simulation will be done. And then afterwards we could check the whole situations of the layer in the OTOM AFP viewer. So for now I click on the mouse on the figure to let the simulation continues. You will see the progress on the main window, which are representing like increasing the simulation progress for a kinematic one. And afterwards, when the whole kinematics, whole layers will be placed, the results are ready to be checked with the OTOM AFP viewer.